Hi everyone, Frank here from targetedtechtalk.com. Today's episode, we're going to be doing an electronics lab here. So I'm going to demo a system that is based on an electronic rangefinder. So that's what we're going to be getting into with today's presentation. So this is an electronics lab project, kind of home lab kind of thing. It's based on a Arduino Uno microprocessor, which is fairly common for kind of home lab kind of setup projects. And it utilizes a ultrasonic rangefinder. So using ultrasound to transmit a beam and then a receiver to kind of pick up the return and then calculate the distance to the object. And then the result is displayed on a little LCD screen here. So I'll be kind of working through this demo. I think this is a fairly beginner-friendly type of project. This would probably not be the first project you do. If you're interested in electronics, you would probably want to work through some of the basic LED and kind of introductory to breadboard and things like that first. But this is fairly beginner-friendly, so it doesn't require a lot of expensive components or a complicated setup. The circuit is fairly straightforward to put together. So let's go through the parts list for this one. So this project is utilizing a small breadboard. Those are pretty common. So that's the little kind of square there with the little perforated holes. That's called a breadboard. Jumper cables, those are the connectors there, pretty common. For the ultrasound, that's the part number. You can kind of pick up a pack of those fairly cheaply. For the microcontroller, I'm using Arduino Uno, which is also fairly popular for doing kind of home lab projects. And for the LCD, I have a specific recommendation. So 16 by 2 LCD is pretty common, which is 16 characters per row and then 2 rows. Specifically, I would recommend this I2C version. You can find other 16 by 2 LCDs that come with the native 16 pin, in which case you kind of have to kind of configure each of the 16 pins. The I2C version includes a chip on the back that simplifies the connection and does some of the setup, like the contrast, for example, the LCD brightness. There's a switch for that. So it kind of simplifies things down to a 4-pin connector, which kind of makes it good for projects. You don't have to kind of natively set up the 16-pin connection. Things are kind of simplified for you. So that is the parts list I would recommend. I think if you buy everything from scratch, at the time of this recording, you'd be looking at approximately $50 if you wanted to follow along with this lab and kind of do it yourself. So in this presentation, I'm providing enough detail so that you can follow along for those interested. But if you're not interested in building it, just kind of understanding the concepts and kind of appreciating the demo is kind of what you can take away from this presentation as well. The connections here, as far as the circuits, it's relatively straightforward. So we're just kind of using the breadboard, no soldering for this kind of setup here. So the ultrasonic sensor, that's the 2 cylinders here. One is transmit, one is receive. It has a ground pin, so that goes to common ground. It has a voltage pin, so that's where it receives its power, the VCC pin. So you'd put that to the common power. And this would be a 5-volt power domain is kind of what we're looking at. So then you've got the trigger pin. So the trigger pin controls the transmission of the ultrasonic pulse, and then the echo pin is what receives the reflection from the pulse. So that picks up the signal coming back. So again, this is ultrasound range. So then we have the Arduino 5-volt pin, powers the circuit here. And then on the ground, going back to the Arduino, common ground, and then LCD, we've got the 4 connections there. So we've got connection to common ground and common common power on the breadboard, and then 2 connections going back to the Arduino, the A4 and A5 pins. So all in all, this is what the assembled circuit looks like. So fairly straightforward as far as electronic projects go. So basically the trigger pin, we mentioned that in the previous slide, that's what controls the transmission. So that sends out the ultrasound waveform, and then the ultrasound receiver, that's the echo pin. So you send out the ultrasound, and then the receiver picks up the return. And basically what this project is doing is it's calculating the distance to the object. So I think I've got a little box in front of the transmitter and receiver unit there. And as I move it around, the distance figure updates. So we can calculate the distance to the object based on the difference between the transmit and the receive. So we send out the pulse for the transmit, picks up the return on the echo, and the time difference tells us how distant the object is. For the LCD output, we've got kind of a standard 16:2, and then my parts list has the specific recommendation for the circuit that will kind of the LCD that will that has the integrated chip on the back that really simplifies the connections here. So from here, we will kind of go to a demo and show you kind of the completed circuit and how it's the LCD updates based on the distance to the object. Okay, so for this next section, we'll be taking a look at the source code that is uploaded to the Arduino Uno microcontroller. So I'll be making the source code available in the article on the website, so you can grab the full copy there. Here, this is the Arduino IDE. So this is the editor and kind of coding environments for Arduino programs. And this is a C++ program if you're interested in the technical details. So I'll just kind of walk through the code and then make this available on the website for those interested in following along. So it's a pretty straightforward program in terms of what it does here. There is some examples out there of similar things. I didn't find anything exactly that was using the LCD system that I was interested in. So I put this together and kind of making the code available for those interested in following along. So the two includes one for the primary one here is the liquid crystal. So this is the LCD display setup. So we've got the defining our pins here. So referring back to the previous connection information about the circuit, we're kind of dealing with the trigger pin and the echo pin on the ultrasound board. So that integrated circuit with the attached ultrasound transmit and receive cylinders. So on the Arduino, that is pin number 15 for the trigger and 16 for the echo. So we just define that as well as a starting offset for the LCD screen here. So the setup function just runs once, and it does some of the initial setup with the LCD. So it initializes it, sets turns on the backlight, positions the cursor, puts in the starting text there, distance sensor, and then puts in the second line text, the range, and then initializes the trigger and the echo pins for input and output. So the trigger pin is an output. So that sends the ultrasonic pulse, and the echo pin is an input, so it receives the reflected ultrasound wave. And then the loop function basically runs continuously as long as the Arduino program is up and running. So we calculate the distance. We write out a low value to the trigger pin, so basically ensuring that it's turned off. We wait a few milliseconds and then basically trigger the high. So that actually sends the ultrasound signal. So that'll create an ultrasound waveform. And then we'll wait 100 milliseconds for that to go out. And then we'll read back the reflected wave and we're doing another, after we send it out, we explicitly turn it off. So we send a high to emit the ultrasound wave. We wait 100 milliseconds, so it is on for 100 milliseconds, and then we explicitly turn it off, just to be kind of explicit there. So that ultrasound pulse should be a duration of 100 milliseconds. And then after that 100 milliseconds, and it's turned off, then we read in the echo. So the pulse in statement reads in the echo pin, and that gives us the length. So then we can calculate the distance based on the equation here. 0.017 is a calculation, and that gives us the distance in centimeters for the object. So this system is kind of a tabletop kind of system. You couldn't use this specific setup at a long range ultrasound, but it is kind of a tabletop thing. So it would work for kind of close range sensors or that kind of application. So then with that distance, we write that back out to the LCD and then print out spaces for kind of the trailing characters of the distance fields. And that's it. So it just basically runs continuously, as you saw in the demo. As the object is moved, it does this calculation and then updates the LCD with the output. And that's our presentation for this week. So in this episode, we demoed an electronics lab project, the Ultrasonic Rangefinder. So hopefully everyone at least enjoyed the video, the content. It's always good to kind of get a little bit of technical exposure and kind of understand how some of these principles work. I think that's kind of a good background. So for those interested in kind of getting more into electronics, this is a fairly good beginner-friendly type of lab. But for those just kind of interested in the topic and the demo, hopefully that kind of presents things. So that is our episode for this week. So thanks for watching, everyone, and put up those likes and shares. Thanks. Talk to you next time.